Hi there, in this video I'm going to machine the Conrods for the Howell V-Twin. So the drawing recommends using 6061 T6 aluminium, but I struggle getting anything like that in the UK. But I think 6082 T6 is a fairly close equivalent. And I've cut a couple of pieces roughly to length and marked them up roughly, just as a guide. And this is wider than that one, and the idea will be that there'll be a groove cut in there and that will run inside it. So I think first of all what I need to do is to go over to the mill and start milling out these holes for the bearings. Okay, so finding the centre of the part using this edge finder. Okay, so I'm working my measurements from this edge here, and eventually there'll be a radius on here of 0.312 of an inch. Now this part is just slightly longer than what I need, so I'm going to be moving the x-axis in by, not by 0.312 of an inch, but by 0.325 of an inch. That'll just leave me a little bit left on here to machine off. So this will need to be reamed to 7/16 of an inch. So this is 27/64 of an inch drill bit. Okay, so I need to move the x-axis this way by 2.2 of an inch, and then I need to drill and ream that position to be 11/32 of an inch, but it's a very similar process to this side, so I'll just do that off camera. So now what I'm going to do is to drill some holes to take some 1/16 of a millimetre drill bits. And these holes will be on the edge of the taper, so later on I can just put some drill bits through and just plonk it on the vise and it will define the taper. So to drill that hole there, I mean, first of all I'm going to use a centre drill. I've calculated the position to be the radius of this outside curve here, which will be 0.25 of an inch plus a 32nd of an inch. So that gives me the x-axis to be 0.2812, and the y-axis is let me see, 0.130 from the centre plus a 32nd of an inch, so that gives me 0.1612. So I'll centre drill and then drill through. with a 1/16 of an inch drill bit. Once I've done that, I'll repeat a similar process on these other ones, using the same method of calculating the position. Well, they seem to turn out okay, so now I think it's time to cut these tapers. So I'm using my usual method to cut the tapers. So I've put a couple of drill bits through the holes I've just drilled, and I've got these parallels on the side. Plonked it on in the vise, tightened the vise up, and on the mill I've just moved the tool down, and I've set the DRO to 0, so that tells me what I'm aiming for. Take these away, take the drill bits out, and I'm ready to start cutting. So I'm just 1/10 thou off my target, so what I'll do is I'll move the x-axis this way, and I'll cut that other area out, and fingers crossed it'll be a decent result. Looks pretty good. So I'll switch it round and repeat the same process on the other side, but I'll do that off camera. Well, so far so good. And I was planning to take the material out here for this to sort of fit inside it, but I've decided what I'm going to do first of all is to machine away all this material here. Okay, so I calculate that I need to take 242 thou off there. Okay, so I'm just going to put some slick gauges on top of this parallel here, which measure 242 thou, 0.242, which is the amount of material I've just taken off that edge, that end here. So If I place it on there, it should be perfectly level. Let's move it up a bit. I think that should be okay. So now it's a matter of removing the same amount of material off this side here. I'll do that off camera. Well, this all seems to be going to plan okay, and now I'm just cutting a groove 70 thou deep. Cutting it to about 65 initially. Couple of turns of the hand wheel. Everything seems to be going to plan. I just need to cut these corners off on the mill. I'll do that off camera, and then I'll get the rotary table set up to do the sort of outside edges. And once I've done that, the last process will be to cut this slot for that. Okay, so I'm using my usual method to turn this end on the rotary table. So this is an MT2 arbor, which is tapped to take a screw, and this has been machined to a height exactly the same height as this 1, 2, 3 block. So I bolted this 1, 2, 3 block to the rotary table, and bolted the Conrod to this centre here, and also to the 1, 2, 3 block. So it's really just a matter of taking small cuts really and going round. And this is an 8mm end mill, a long one. Which is a sort of need for this depth, but I'm not too sure whether 8mm is going to be too big once it gets to these corners, but we'll see how we get on. Well, it's proving quite difficult to get into these corners, so I think I might just concentrate on the 2 outside edges at the moment. So all in all, I moved the table in by 128 thou to get this nice sort of curve here, but I'm just struggling getting in here. So I think what I'm going to have to do is to change this to a smaller diameter, which will only cut to maybe half the length, and then switch it round and do the other end. Well, that seems to have worked pretty well actually. So I'll continue using this method. So I'll do this other side and then I'll switch it round and then finish all that off. But I'll do it all off camera. Seems to have turned out okay. Probably a little bit of tidying up with a file, but not a bad result. And one thing I forgot to do was to take these corners off on the mill. So I think I'll end up using a file to take those off, just to tidy it up. So for all these other sort of radiuses, I'm just going to follow exactly the same process. So I'll get back to you once I've done that. Okay, so now to cut the slot in this, and I put an edge finder on the inside of the jaws of the vise to find the centre, and that should be put me spot on the centre of the little end. And I need to cut a slot in here 0.4 of an inch wide, so this is 10mm end mill, just short of that at the moment, and I need to cut to a depth of let me see, 0.662 of an inch. So what I'll do first of all is get to that depth, and then I can just take a slight edge off each side. So this needs to be 0.4 of an inch wide, and currently it's 10mm, which is 0.3937. So that's 6 thou over, or 6 thou and 3/10. So what I'm going to do is I'm going to move the y-axis that way, just over 3 thou, make a cut, then move it this way in the opposite direction, just over 3 thou, make another cut, and hopefully that'll get me to my target. That's just a touch on the tight side, but I think I can make an adjustment on that just by taking a little bit off with a file. Well, after a bit more practice on the rotary table, I managed to get a better finish on the edges using this 10mm end mill. It's a bit of a dog's breakfast is that one, but and that one. But the other ones are alright. And I've got a pretty good fit in there. Happy with that. So what I need to do now is to just make some bearings. So a bit of Loctite 638. Well, the reamer goes through it okay, so I'm happy with that so far. Well, I was eager to see how this might look, so I made a little crank pin. I must say it looks pretty good. One thing I haven't done is to drill an oil hole in there, so I need to do that at some stage. And obviously I need to make the bushes for the little end. And but I think I'll leave that until I make the piston and the gudgeon pins. But slowly coming together. Well, having done the motorcycle CBT, I took a lesson on a Kawasaki 650. Man, it was fantastic. Really, really good fun. Learning all the techniques that you need to learn. Took it on the road. The only downer was it was raining and it was freezing cold, and I don't think my family are very happy with me going down this route, so I think I might have to rethink things. I might have to come up with a plan B, whatever that might be. But anyway, I hope you enjoyed this video. It seems to have turned out pretty well, and I hope to see you later.